This is homework number 4, question number 5, and what I see starting out in this equation, just with the parentheses, is that this is going to be an exact differential equation. Now, we have to test and make sure that it's an exact equation, and to do that, I'm going to go ahead and label these two functions or parts of the equation. I'm going to label this one m, and I'm going to label this one n. Alright, so now that that's done, we're going to take the partial of m with respect to y, and when solving for that, that'll give you secant squared x, and now we're going to take the partial of n with respect to x. In doing that, that will also give you secant squared x. Now, since these two partials are the same, the equation is exact, and you can solve it with the rest of the method. Now, before I go on, I want to go ahead and relabel these two functions. I'm going to label this one fx, meaning partial derivative of x, function partial derivative of x. I'm going to label this one fy. So now what we're going to do is we're going to take our fy value and we are going to integrate it in order to put it back to the original function. And when you integrate fy, that'll just give you f. You integrate tan x plus 2y, that will give you y, because we're integrating it with respect to y to get rid of the y. So that'll give you y tan x plus y squared 2 over 2, which just equals 1, plus a function in terms of x. We can't say it's a constant because there might be a function that we missed in terms of x. Because when you're taking a partial derivative of x, it becomes 0 because x is treated as a constant. So now what we're going to do is we're actually going to derive this in terms of x. So make this fx, which is equal to secant squared x times y plus 0, because there's no x value, so therefore it's 0, plus h prime of x. Okay, now what we're going to do? Well, we're going to take this fx value and set it to this fx. So that's going to be secant squared x y plus h prime of x is equal to y secant squared x plus secant tan. Now we are going to solve for h prime of x, and when you do that, you will get the h prime of x is equal to secant x tan x. Now, this doesn't help us much for the regular function equation because this is h prime of x. This is just h of x. So we're going to have to integrate that in order to say that h of x is equal to secant x. Therefore, we can say the general solution is going to be y tan x plus y squared